optimization. So I think the optimization is a very popular term for computational design because everyone wanted to optimize their design process or fabrication or whatever. I mean, the automation and optimization is actually give us you a better profit, right? So this is one of my project as an example of optimization. This project is to think about parking lot in Singapore. So at that time I worked at Flux. We have a client in the Singapore, and then they ask us like, okay, so we have a random boundary site, and we really wanted to make a very compact parking lot there, which fit our law. We have a precast, like a modularized system that actually assemble entire parking lot. So we create some sort of grid optimizer in that context to compare which one is better, or we can assign some particular rule that possibly affect the result of optimization. So which is really fun because in terms of optimization, I guess the more restriction or confinement limitation inside my imagination how machine or how algorithm react. So which is actually really fun. Just think about it. We can set up a ecosystem or environment, and then we set up some rule or some sort of like a hierarchy or ecosystem and how they react to each other. Let's say create a game environment, and then we can give us some particular circumstance or situation, and then we can monitor how they react, and then based on their reaction we can parse the information as a result. We can keep tracking. Actually your action is become part of the design process, and then this action is a result. This action is causes the other result, and the other result is like a chain effects. So we can capture this kind of entire action series and then compare different action series. Yeah, you got my point, right? So also in this project is we have two different modes. One mode is like a 100% optimization using brute force algorithm. The second thing is that we wanna play with the parameter. Yeah, but at the same time we want to see the option and list above 90% in that building. So we open all parameter. Even we can actually categorize like a ranking system, like for example where is the entrance, right? So because the entrance is possibly affect entire shape of parking lot, right? And also what if we wanted to have more sunlight? I mean, just forget about the parking lot, just think about like a residential building. Yeah, so we can also integrate this kind of algorithm on top of this optimization. Yeah, so we can achieve it by dealing with data and set up the algorithm to cook the data structure that possibly process the data. Let's jump to other topic, data and structure. So I mean, structure itself is a very different story, and it's like it's not a fun. It's like a more serious things. Very hardcore engineer, they're dealing with the data very seriously to prove the structure or optimize the structures. But in this project, it's more about like explore the design options based on the rule. So as you can see, we wanna install a loop in that place. What is the best places for locating columns to support ceiling, right? So in this context, we set up the rule, and then each iteration, the column is actually try to move to the direction that support more weight. Yeah. At the same time, there's a people representing a particle that actually push the column because I don't want column. Yeah, I want to just walk. Yeah, the column cannot be block me, right? And also at the same time, there's even some building or some fixed situation or some void space. Also, we can take advantage of this kind of a given situation. So we can dump this data and then set up the right data structure to process the data, and then we can see how each rule can fight each other in order to meet some particular result that we can consider as an optimization, the best place in given situation. So what I'm trying to say is that at least to play with data, give you some good sense of how you interrupt the design process and how to set up your own decision-making process which one is like, something like, think about like the tree structures, like it has so we have a root, right? And then the branches comes up, and sometimes we need to diverge or converge in order to explore this possibility, let's say design options, because some options actually meet some particular criteria, but the other one is sometimes it's not meet other design specifications. So I mean, computation design is more about like as a god, set up the ecosystem and interrupt the ecosystem iterative way to see what is the best outcome that you are looking for. So I mean, this kind of approach and stance is also really good example what is the data in design. This is some plugin I developed. You can actually download from Food for Liner. I mean, because geometry is the most essential and basic ingredient or resources, because you are designer, right? You're gonna make something in space. So in this context, we must understand the geometry concept. So in that plugin, help us designer to focus their own design process by taking advantage of like a necessary analysis of shape that you are playing with. I just wanted to remind of you guys to, I mean, basic is always important. So what is the basic data for design? Yeah, obviously point, vector, line, polyline, or like surface or mesh. This kind of object is full of data actually. I mean, previously we talked about the data in design. It's really hard to dealing with the data directly. So what I mean by that is we need to remap, or not remap, it's like representing some data in space as a geometric concept, like point or vector flow. So no one actually think about, maybe it's really hard to understand, let's say 4 number to indicating wind, X, Y, Z, and time or strength. Yeah, but we have only one vector. We can easy to visualizing the numeric information as a visual information, right? So in this context, I think the geometry is needless to mention. Geometry has a flow of data, which is really important for us.